All right, now here's 165. This time they give us g of x, and they want to know where it has a relative minimum. Notice this is not a derivative or anything, so let's just plug that in the graph. It's going to look like a relative minimum. So there's our graph. We just need to find that minimum point. So I'm going to do menu, analyze graph, minimum, click, click, 2.242. The answer is C. All right, 166. This time they give us a derivative. They give us a point. That should tell you you have to use the first fundamental theorem of calculus. So you're going to have to set this up. It's going to be the integral. And then we have to use this point that they gave us. So the first bound is going to be a 3. Then I use the point I'm looking for. So it's a 6. Make sure these are in the right order from smallest to biggest. And then it's going to be the antiderivative of f prime of x is going to equal, pretend like there's a dx there. I'm not writing that. F of 6 minus f of 3. Yep, that's a 3. Okay. So now your calculator is going to do all this for you. Let me get out of this. So just go back to a normal calculator page. First thing we're going to do is we're going to evaluate this integral. So menu for 2 from 3 to 6. Nope, not like that. Of the square root sine x. Oh my god. Plus cosine x. Plus 2. So you should get 3.198. So now we have to set up an equation here. So we know this is 3 point whatever. Blah, blah, blah. Equals. We're looking for f of 6 here. And then they tell us f of 3 equals 4. So this is going to be minus 4. So 3.198, which is here. I want to get f of 6 by itself, so I'm just going to add 4 to that 3.918. Which gives me 7.198. So our answer would be D. When you're going to use this method, you should always be given a derivative, a point, you're looking for another point. Same thing for this one. I'm not going to write it out just to save us all. We have a derivative, a point. We're looking for another point. So I'm going to set up my integral. This time it's going to be from 1 to 4 of natural log x squared plus e to the x dx. So we should get 8.619. And we know that should equal whatever our top bound was, so f of 4, minus f of 1. Now the difference in this one, this time they give us f of 4, so I know this is going to be negative 3. So I'll add 3 to both sides. So then I get 11.619 is going to equal negative f of 1. So that means I need to divide by a negative 1. So my final answer should be negative 11.619, or A. So if you're ever looking for the second one, you're going to be left with a negative divided away. All right, next. This one uses the second fundamental theorem of calculus. So they give us f of x. We see this integral with an x as your top bound. That should be your first hint. So right away we can take our first derivative. And that basically just means that your integral will go away. So it's going to equal cosine, the square root of x. But now I want the second derivative at 6. So we're just going to use our calculator to find that derivative. So menu for derivative at a point. I'm looking for it at 6. Then I'll just type in cosine of square root of x. And you should get negative 0.130, or C. All right, same thing for 169. They give us this weird derivative of an integral. So we're going to take that first derivative. So our first derivative is just going to equal the function that's inside. So it's going to equal t cubed minus natural log x plus 4. So now this is the first derivative. So if I want to know where the f of x is concave down, I'm looking for a place when my first derivative is decreasing. So I'll just use my graph. And plug it in. Sorry, that t should be an x, not a t. Can somebody let Sandy in? And then if I want to know the interval where this is decreasing, again, I'm just going to find this 0. So menu, analyze graph 0. And we should get 1.80. So it's going to be decreasing to the left of that because it's negative. So from negative 2 up to 1.180, which would be C. 170 is total distance traveled. You should be thinking of setting up an integral with an absolute value of velocity. So back to our calculator. So we're going to do menu for 2. And I want the total distance from 0 to 4. So 0 to 4. Total distance traveled, I need an absolute value. So not the book. Hit the number next to the book. Go away. Absolute value. And then I type in 3 e to the power of cosine x minus 2 dx. Hit enter. You get 7.72. Just don't forget the absolute value or else it would give you something else. So our answer is D. This one, it gives us a velocity. They tell us the position at 4. They want the position at 3. So it's going to be the same type that we just did, where we set up an integral, and it's going to be equal to f of 3 minus f of 0. So in this case, it's going to be menu 4, 2. The two positions we have are 0 and 3. Nope. Then the velocity is natural log x plus 2 plus 2 cosine x dx. So we get this 3.943, and that's going to be equal to the position at 3 minus the position at 0. And I know my position at 0 is 4. So that just means I have to add 4 to both sides here. So I'm going to take this 3.943, add 4 to it. You should get 7.943, which is C. All right, next one is kind of like a FRQ question. They tell us W is the rate it's being poured into the tank, R is the rate it's removed, and they want to know the amount of gallons after 3 hours. But they tell us we start with 20 gallons in. So it's going to be 20 plus the integral from 0 to 3. And then it's going to be the rate that it enters, so that's sine 2 to the power of x plus 3 minus this other one, so square root of natural log x plus 3 plus 5 dx. And we get 22.267, which is D. (173) is talking about area. So we have e to the x, cosine, blah, blah, blah. We want the area of R. So this is a long problem. Basically, we got to find the intersection. Oh, no, we don't. They're right here. It tells us it's from 0 to 1. So basically, we're going to set up an integral here. Menu 4, 2. Our x values go from 0. This line cuts it off at 1. So it'll go up to 1. And then because it's area, it's just going to be top function minus bottom function. So it'll be e to the power of x minus cosine of x squared. And it gives you 0.813. So close. 174. This time it wants cross sections where it's squares. So essentially the same thing. Unfortunately, this time you have to find where they intersect. So we're going to do the same thing here. We just got to type in both those functions. Oh my god. 3 natural log x plus 1. And x squared. So obviously this first one is 0. We just got to find the second one. And I get 1.7384. So now I'm going to go back to a calculator page. I'll do my integral. And then it's going to be from 0 up to that other intersection point, which was 0.7384. And then because it tells us cross sections are squared, I'm going to do top minus bottom. The area of a square is side squared, so I'm going to square top minus bottom. So it'll be 3 natural log of x plus 1 minus x squared. Then all of that squared, because they told us it was a square. And you should get 1.180. Just go open the door. All right, last one, 175. Volume of the solid rotating around the line y equals -2. This is going to be a washer method. Thankfully, they give us the points where it intersects. So we're going to do an integral here, menu for 2, from -2 up to +2. And then I need to find my big radius, so it's going to be obviously G. Which one is it? That's g of x. So g of x is x squared minus 1. And then we subtract the line we're going around, so minus -2, which is a +2, squared, minus my little radius, which is, wait a second, that's the wrong line. Sorry, this one should be the other one. This one should be square root of x plus whatever. And then minus the other one, which is x squared minus 1 minus -2, so +2 squared. So this is just washer method, finding big radius, little radius. That's not a 2. That's not an answer. Oh, I forgot the pi. Multiply it by pi. My bad. There we go. It's C. If you ever get something that's not an answer, make sure you have a pi. And that's it. That's all 175. Bye.